In Chapter 8, we're going to continue our work with exponents. Last chapter we worked on multiplying and dividing exponents. Well, in Lesson 1 we're going to talk about what happens to our exponents when we add and subtract them. Okay. Out of this chapter we want to be able to write polynomials in standard form, and we also want to be able to add and subtract polynomials. Your Common Core standards, we want to be able to interpret parts of an expression, such as terms, factors, and coefficients. We're going to talk about that in a minute. And we also want to be able to add and subtract polynomials. And we've also done some multiplication and division last chapter, but we're going to get into more detail later in the chapter. You do have some new vocabulary words: polynomials, binomials, and trinomials. Now that came up, I think, at the beginning of last chapter, but we're going to revisit those. We also want to talk about the degree of a polynomial, what that means when we talk about degrees. So let's talk about that first. We want to be able to state whether an expression is a polynomial. Okay, just by looking at it, can we tell if it's a polynomial? And if it is, what type of polynomial is it? Is it a monomial, binomial, or trinomial? So let's take a look here at our chart. Here's our first expression. 6x minus 4. Is it a polynomial? Yes, it is. Because we have it's a difference, we're subtracting, okay? And we have no negative exponents here. We don't have any variables on the bottom of a fraction. Okay, and because we have 1, 2 terms in this is called a binomial, because bi means 2. Okay, so a 6x is a term, 4 is another term, and it's a binomial. Okay, now let's look at x squared plus 2xy minus 7. This is a polynomial because we're separated by pluses and minuses. Okay, and we don't have any negative exponents, nothing on the bottom of a fraction. And because we have 1, 2, 3 terms, it is a trinomial. Okay, now let's look at C. We have 14d plus 19e to the third, all divided by 5d to the fourth. This is not a polynomial because of this bottom right here. This would give us a negative exponent. If we put this on top, it would be d to the negative fourth. Or we have it in the bottom of a fraction. Because of this, right here, it's not a polynomial. Okay? And our last one, 26b squared, it is. This is a polynomial, okay? There's no fraction with the variable on the bottom, and it has one term, and since it has one term, it is a monomial. Okay? So that's really all you're looking for. How many terms are there? Because that tells you the difference between a binomial, trinomial, or monomial. And you have to check to see if there are any variables on the bottom or any negative exponents. If there are, not a polynomial. Alright, so why don't you try a couple, check your progress problems, and then we'll check them. So go ahead and pause the video. Okay, let's look at A. State whether 3x squared plus 2y plus z is a polynomial. If it is it a monomial, binomial, or trinomial? Well, it is a polynomial because, again, we're separated by pluses, and we have no negative exponents or exponents in the denominator. And we do have 1, 2, 3, so it's a trinomial. Okay, let's look at this one. 4a squared minus b to the negative second. Is that a polynomial? Well, no, it's not, because of this negative 2 right here. Okay, that negative makes it not a polynomial. Alright, let's look at C. We have 8r minus 5s. Yes, this is a polynomial, and it's a binomial because we have two terms. 8r is a term, 5s is a term. And finally, D, 3y to the fifth. Yes, it is a monomial, and it's a monomial. We have one term, 3y to the fifth. Okay, that's one term. Alright. Well, now that we know our vocabulary, let's work on writing them in standard form. We've talked about standard form before when we were doing slope-intercept form and point-slope form, and it's still the same thing. We're going to put them in order. The standard form we talked about before was 8x ax plus by equals c. Okay, it's still kind of the same thing here. We have 9x squared plus 3x minus 4x, and we want to put it in standard form, and then we want to identify the leading coefficient. Well, in order to put it in standard form, we need to find the degree of each term. And by the degree of each term, I'm talking about its exponents. So if we take a look at our polynomial here, 9x squared, this has a degree of 2 because its exponent is 2. This has a degree of 6, and this has a degree of 1. Okay, we're looking at our exponents. And so in order to put it in standard form then, we put them in descending order. So since this is the highest one, it goes first. Then we go to the next one, and finally the lowest one. So 3x to the 6 plus 9x squared minus 4x is written in standard form, descending order. The leading coefficient is, well, what's the coefficient of the highest degree? What is leading our polynomial here? So the leading coefficient is 3. Okay? Let's look at another one. Now this one's a little bit more complicated. We have 12 plus 5y plus 6xy plus 8xy squared, and we want to put that in standard form. And you can see that we have x's and y's in two of our terms here. So let's find the degrees. Now look how we do this. 12 has 0, okay, because it doesn't have a coefficient, or it could be x to the 0. 5y has an exponent of 1. 6xy, the reason it is a second degree polynomial is because we have a 1 here and a 1 here. So 1 and 1, total is 2. For 8xy squared, x has an exponent of 1, y has an exponent of 2. So 1 plus 2 is 3. So this is actually going to be your highest degree term. Okay? So when we put them in standard form, we want to lead with that highest coefficient, or that highest exponent. So it becomes 8xy squared plus 6xy plus 5y plus 12. And your leading coefficient is 8. Okay? So if you have more than one variable, you're going to have to add the exponents. Alright, why don't you try your progress problems and then pause the video. Alright, write negative 34x plus 9x to the 4th plus 3x to the 7th minus 4x squared in standard form. Alright, here you go. This one was a little bit simpler because we only had one variable in there. So we start with our highest and work our way down. Okay? Your leading coefficient would be 3. Identify the leading coefficient of this polynomial when it is written in standard form. Well, first what we have to do is put it in standard form. So let's take a look at the degrees here. 5m has a degree of 1, 21 has a degree of 0. This has a degree of 2 because we have a 1 and a 1. This has a degree of 4 because m has an exponent of 1, n cubed has an exponent of 3. So together they make 4, and then we have 72n cubed, which is 3. So now that we have these, let's rank them, put them in order. And we have 8m n cubed minus 72n cubed minus 6mn plus 5m plus 21. And its leading coefficient is 8. Okay? Alright, so let's look at some problems. How do we add polynomials? Okay, very easy to do, and in fact you've actually done this before. In order to add, you have to add like terms, which means they have to have the same variable with the same exponent. Okay, so if we take a look at this expression right here, we're adding these two sets of polynomials. Now when we add them, really all you have to do, the book shows us two different ways to do it. We can do it horizontally, okay, which is kind of the way that I will do it. It's the way I prefer, but you can do it either way, I don't care. We're going to add like terms. So you can see that 7y squared and 5y are both in red because they're like terms. They both have a variable of y and their exponents are 2. So since they have the same variable with the same exponent, you can add them together. So 7y squared plus 5y squared is 12y squared. Notice we didn't change the exponent here. When you add or subtract, nothing happens to the exponent. It's like saying I have 5 apples plus 3 apples. That's 8 apples, not 8 apples squared. Okay. Our 2y and our minus 4y, they are like terms because same variable, same exponent. So 2 plus a negative 4 is a negative 2. And then we have our constants, negative 3 and 2. Now this is the horizontal method. If you prefer, you can do it using the vertical method. And the vertical method is just that. You're going to line them up with like terms on top of each other. Okay, kind of like what we did with elimination method. Okay, it doesn't matter which way to me. We'll still end up at the same answer. Okay. Here's another example. Horizontal method, again, like terms. 4x squared, negative 7x squared are like terms. 2x and 3x are like terms, 9 and 7. So when we add them, you don't necessarily, I don't even care if you don't even do this step right here. Okay, if you know that 4x squared minus 7x squared go together, you can skip this and just give me your answer here. Okay. If you want to do it horizontally, vertically, again, you're just going to put your like terms on top of each other and add. Okay. All right, go ahead and check your progress problems and pause the video. All right, if we add this polynomial together, okay, I went ahead and I circled like terms. So 3x squared minus 5x squared, they're like terms. Your 2x and your 3x are like terms. Your negative 1 and your 4 are like terms. So you should get an answer of a negative 2x squared plus 5x plus 3. Now that you know how to write polynomials in standard form, your answer should be in standard form as well. Okay. The next one, 4x cubed. Well, it's the only 4x cubed here, so it's just going to stay. It doesn't have a buddy to add with it. Your x squares are like terms, your x's are like terms, and your constants are like terms. So final answer should be 4x cubed plus 5x squared plus 30x plus 6, or 3x, plus 6. Okay? Now, when we go to do some subtracting, you have to kind of do an extra step, okay, because of this subtraction sign right here. And again, they are going to show you vertical and horizontal method. I don't care which way you do it. Okay. Now, here's where you have to be careful. You are subtracting everything inside the set of parentheses, which means the signs are going to change. Okay? This becomes a negative 4y. This becomes a positive 7y. This becomes a negative 2y squared. Once you do that, okay, then you can go ahead and you can start adding your like terms up. Okay, let me show you. To me, they're doing a little bit too much work here. I want to make things a little easier for you. So let's go ahead. Let me show you the vertical method. See how they have add the opposite. Okay, again, they changed positive 9y to the 4th to negative, positive 2y to negative 2y, and so on. Let me show you how, this is what I would do. Here's your first check your progress example. I rewrote it distributing this negative to each one of these terms. Okay? Once I did that, then I can add like terms. 3x cubed, negative 5x cubed. 2x to the second, negative x to the second. And when you do that and you simplify it, you should get an answer of x to the 4th minus 2x cubed plus x squared. So I'm going to go ahead and pause the video and you guys try B. Alright, so if you distribute that negative, it should become a negative 6y to the 4th, a negative 5y cubed, and a negative 9. And when you simplify, there's your final answer.